So in your book, lesson 9.4 is the last lesson when it comes to this unit. However, if you will remember, all of the things we've been doing for this past week and a half have been looking at the surface area. We're going to go back then after these 2 days and go and look at lesson 9.1, where we take these three-dimensional shapes and we figure out how much they can hold, how much it would fill them up as we look into volume. We're going to continue on today, though, with the idea of finding surface area. Once again, finding the area of the shapes that make up the three-dimensional object. And in this situation, we're going to be using squares. So we have the formula for area of a parallelogram, and triangles. So we have the area of a triangle, base times height divided by 2. As I go through these, then, once again, I'm going to have them set up in images for you so you have the specific process to go through on each and every one of those. Those will be available to you on Canvas as you are ready to do your assignment. So what we're looking at then is being able to represent and create from a pyramid, either triangular pyramid or a square-based pyramid, and have a net, and then using that net to solve for the surface area. Once again, how much would it take to cover the entire outside of that particular shape? When I look at these then, I have what is called lateral faces. So lateral faces or vertical sides, those are the sides that are going to be standing up. So they will all have a base. On the left, you'll see a square base pyramid. So its base is a square, but then its lateral faces, the sides that stand up and come to that point, come to that apex, they're going to be triangles. And there's going to be 4 of them because the base has 4 sides. In the same way on the right, you have a triangular pyramid, and it has 3 lateral faces. There are 3 triangles that are going to stand up and come to that apex or to that point of the pyramid. When I look at these then on the handout that I gave you with the different images, the one on the right is not actually there because I gave you a specific type of triangular pyramid, which is called a tetrahedron. So a triangular pyramid can have a small base and then really long sides for the lateral faces, or it could be vice versa. It could have a large base triangle and very short lateral sides. With a tetrahedron, you're going to have 4 equilateral triangles. So each of these 3 is going to have its own formula or its own setup. And once again, I will provide that for you on here as well as on Canvas. So as we go through it, it's just going through the process to figure out what the surface area is for each and every one of these shapes. So if I have a square base pyramid and I have the measurements that are given, I should be able to calculate the area of the base, in this case is a square, and all 4 of the lateral faces or vertical sides, which are going to be the 4 triangles. As I do that then, I'm going to use my basic formulas as I begin to set it up. But I'm going to try to, once again, do my best to make it a little bit easier for you and combine some steps if we possibly can. The first thing we need to do is understand, well, how do we draw our net from this particular three-dimensional shape? So when I see that it's a square base pyramid and they're showing me that the base is 4 by 4, then I start by making a square in the center of my graph paper, and I make sure that it is 4 units going across and 4 units going up, and then I fill in the shape so it has all 4 sides and makes a square. Then I use the measurements of things such as the lateral side. Now, notice we have nice little boxes to draw in, and this says it goes up to 7.23. So this isn't going to be an exact measurement when I'm drawing this on graph paper, but it's okay. It just gives us a basic idea. And this particular shape that the book gives you, that's going to be the type of net that I suggest that you draw as you're doing these so that you can just label it and be able to figure out what math problems you need to do to find the surface area of your square-based pyramids. So when I look at this particular one then, notice it is a triangular pyramid. And when I look at the different measurements, I can see that all the bases are 9, and that my slant height, or my height of my triangle, is 7.8. So when I create that net, then I'm going to see that I have the same size triangles throughout. They're showing you two different heights of your triangles to show you that the base triangle and the vertical side triangles, or the lateral side triangles, are the exact same triangles. So these are equilateral triangles. So I'm going to make sure that I have 4 of them drawn, and it makes one large triangle, nice and straight sides. That, once again, is called a tetrahedron. And then I could take my base times height divided by 2, the area of a triangle, and find the measurement for each of those 4. Now, as we do these, I'm going to ask that you do just as I asked you to do in the previous lesson. I want you to draw a generic net and then label it so you know which numbers go where in order to set up your calculations. Well, what calculations are you going to do? Well, your calculations that you're going to do are for parallelograms and for triangles. Once again, these are all going to be square-based pyramids. You could have a rectangular-based pyramid, which kind of sets things up differently, but that's 7th and 8th grade geometry and not 6th grade. So we're going to do square-based pyramids, and I know a square is a parallelogram, so I'm going to do base times height. I'm also going to look at the sides, which are triangles. So just as I asked you in the previous lesson to draw nets to help you figure out where the numbers go in order to set up your calculations, I'm going to ask you to do the same thing here. So if you have your colored half sheet that I printed out for you that has all the nets on it, then you'll see what the net is for a square-based pyramid. If you don't, well, once again, that's on announcements on Canvas, and you can take a moment or two to look it up and be able to figure out what it is to draw. So when I make my generic net for a square-based pyramid, I simply start with a square, and then I try to make triangles that look very similar all the way around it. Now, I drew these with, the tool to draw triangles, and I duplicated it so mine looked nice and neat, but if I was doing it with my hands, it wouldn't look as neat as this. But you get the idea. I have a square on the bottom, and I have 4 triangles that make up the sides. Right? And then I have to label it. So I'm going to label it with the measurements that are given. I can see that the base of this particular pyramid has measurements of 6. Both sides would be 6 because it is a square. So I'm going to measure both sides as 6. And then I should know, that whatever the sides are of those squares, those are also going to be the bases of each of the triangles. So I know already the measurement for the base of the triangle. Now I just need to label the height. So that slant measurement, or that vertical height, is 8 centimeters. With that information, I'm going to set up my steps in solving the areas that I'm then going to add together. The first one is the base. It's a square, straightforward parallelogram, base times height. So I plug in 6 times 6, and I'll know what the height is. The triangle then. So let's look at what we talked about in our previous lesson when we did a triangular prism. And we talked about when I had 2 sides that were triangles, I would have base times height divided by 2, but then I would be multiplying it by 2. So that would just cancel it out. So if canceling out with 2 triangles gives me a straight base times height, what do you think we'll do if I have 4 triangles? Well, if I would plug that in as base times height divided by 2, which is the area of a triangle, and I have 4 of those, I'm going to start by cross-reducing the 2 and the 4, because 2 will go into 2 one time, and 2 will go into 4 2 times. So what we're seeing is, if we have a square-based pyramid, and I can find the area of the base, then when it comes to the triangles, all I have to do is base times height and multiply that by 2, because that would take care of the area of all 4 different triangles, right? So if it's a square base, then all I have to do is take my vertical sides, my lateral faces, and multiply it by 2. So 4 triangles is going to be used when we're doing square-based pyramids simply as 2 times the base times the height. So once I have these 2 formulas for my process of finding the surface area of a square-based pyramid, then I'm just going to start with the base. And in this particular example, the base is a square that has measurements of 6 times 6. So I plug that in, and then 6 times 6 is 36. When I do my triangles then, I can see I'm going to take base times height. In this case, for this triangular pyramid, the base is 6, just like on the square, but the height is 8. So I'm going to have 8 times 6, but I'm going to have that all multiplied by 2. Because once again, there are 4 different triangles, and originally I would have base times height divided by 2. Well, if I have 4 times all of that, I'm just going to get rid of that and have multiplied it all by 2. Therefore, when I do 8 times 6 and I get 48, 48 times 2 tells me that my vertical sides, my triangles, are going to be 96. To find the surface area then, I just add those together. 6 and 6 is 12. Put down my 2, carry my addition of 1. 9 and 1 is 10 plus 3. That gives me 13. So what we found is that the surface area of this square-based pyramid is 132. Notice that the label is squared. So I keep the label of centimeters, and since I'm finding area, I would be multiplying 2 different measurements to find the area, and therefore it is going to be squared. All right. Let's look at a different one that has longer sides to it. It does not change how we do the math, right? Now this net's already drawn for me, so all I need to do is plug in my steps and my information from the net that's given to me. So once again, I'm going to make a generic net and label it. Well, that part is done. So now I'm going to take my 2 steps, finding the area of the base, finding the area for the 4 triangles, and then adding them together. So when I look at the base, I see that I have 1 measurement on my net. Well, once again, it's a square, so all 4 sides have to be the same measurement. So I'm going to take my base of 4 times 4. Well, 4 times 4 gives me 16. Then I'm going to look at my area for 4 different triangles, and I'm going to say, well, I know that I'm multiplying it by 2 because there's going to be 4 triangles, and each triangle is only a half. And then I have to use the measurements that I'm given. Well, the base of the square is going to be the base of the triangle, so I know I'm going to have 4, and then I'm going to multiply it by its height of 7.23. So 4 times 7 and 23 hundredths, well, you can take your handy-dandy calculator and multiply those, and you would find out that that's 28 and 92 hundredths. Well, if that's the case, then I'm going to multiply that by 2. I'm going to double it. And that gives me 57 and 84 hundredths, or 57.84. So that is the measurement of the area of the vertical sides. But I have to add that to my base. Notice when we're lining this up, we have the 16 offset to where the 1s in the 10th column are lined up together. That means I have that decimal, so I have to fill in with decimals and zeros so that everything lines up correctly. And then once I have my decimals lined up and zeros filled in, I bring my decimal down always and forever before I start adding. Well, then 4 and nothing is 4, and 8 and nothing is 8. Then I have 7 plus 6, which is 13. Put down my 3, carry my addition of 1. And then 5 plus 1 is 7. Looking at my measurements, I have centimeters once again. And once again, since I'm finding area, multiplying 2 different measurements on each of my shapes, then I know it's going to be squared. So my answer is 73.84 square centimeters, or 73 and 84 hundredths square centimeters. So we're just going to follow that process each and every time that we have a square-based pyramid. 2 math problems that we then add together, so 3 total steps. So I want you to do your best on this one. Come back and check after you have your answer, and let's see how we do before we move on into triangular pyramids. So hopefully you have your answer and you thought about the steps that we needed to do, which was starting by making a generic net and labeling it, and they've already done that for you. So hopefully you then looked at the square, you began to set up your first formula, base times height for the base, and that base has measurements of 4.8. Right? So if I had 4.8, I have to multiply it by 4.8 because it's base times height. And then when you type that into your handy dandy calculator, hopefully you got 23.04, also known as 23 and 400ths. Then when you looked at your height, your triangle, your vertical sides, then you set it up. We know once again the area of every triangle is half. So therefore, if I have 4 of them, 4 halves make 2 wholes. So we're going to take 2 times our base times height for our vertical sides, which are triangles. And if the base and side measurement of the square is 4.8, then the base measurement for that triangle has to be 4.8 as well. Its height is indicated with the dotted line and the right angle, so it's perpendicular, so it has to be 8. Once again, order of operations, we're going to multiply on the inside parentheses first, and 4.8 times 8 gives you 38 and 4/10. Then when you double that, you end up with 76 and 8/10. So notice I continue to add over to the side my measurement for my base, because a very common thing that happens is the students will go through that second step. They'll find the area for the triangles, those vertical or lateral sides, and then they stop and they circle the 76.8. So I can see that 23.04 or 23 and 400ths over there to the right, sitting out by its side. That's just my own personal reminder that I have to then go to the last step and add all of them together. So I take my 23 and 400ths. Notice I've lined up my decimals with 76 and 8/10, and then I'm going to have to fill in with a 0. And then before I add or subtract decimals, I always bring my decimal down. And now I have 4 and 0, which is 4, 0 and 8, which is 8. Then I can add both of them. 6 and 3 is 9, and 7 and 2 is 9. So we found, hopefully, that you found 99 and 8400ths, or 99.84. Looking at your label, this one is in centimeters, it's inches, so you had to square your inches as your label. So hopefully that's the answer that you found. If it's not, do you see where your mistake was? And if you don't, please ask us for help so we can help you find and locate what the answer is. Now, before we go on and shift gears into the triangular prisms, I just want to pause for a moment. I don't ever want you to go up in middle school and high school and think, well, Mr. Barker told us there were only 2 types of pyramids, triangles and square base pyramids. And that's not the case. Those are the ones that we talk about in 6th grade. When you get into your higher levels, you can see that any polygon that you make out of a base can then be created into a pyramid. And that's the kind of math you'll do later on in geometry when you get older. So now we shift gears into our second one then, and that's the triangular pyramid. And we're going to look at 2 different kinds, because there are 2 different kinds of triangular pyramids. There is this one, which is a special kind, which has the easiest math out of all pyramids, because it has 4 equilateral triangles. It has a special name, which is tetrahedron. A tetrahedron is a triangular pyramid that is made up of 4 equilateral triangles or congruent triangles, which means all 4 of them have the exact same measurement, the base as well as the lateral sides. When I look at the net of a tetrahedron, there are 2 different ways that you can draw it. The top one there where it says net 1, that's the one that's on your handout, I believe. But the bottom one would also work, because I could take all 4 of those equal triangles and fold them equally and create this tetrahedron, or this equilateral triangle pyramid. It's much easier to say tetrahedron, even though that's a big word. What makes this easiest is that when I look at it, then I can see that all of my sides have the same measurement and all of my heights have the same measurement on all 4 of my triangles. I have all 9 meters on this particular one, and the heights on all of them are 7.8 meters. So what that tells me is if I use my formula for a triangle, which is base times height divided by 2, but I have 4 triangles that are the exact same, just as we saw with the square base pyramid, then I can cross reduce that 2 and that 4 first, and know that 2 goes into 2 one time and 2 goes into 4 2 times. So I can use that straightforward if I have 4 equal triangles and just do 2 times the base times height. The reason, once again, this works is that a triangle is always half of an area of a parallelogram. And if I have 4 of them, 4 halves make 2 wholes. So plugging that in, I know I have 4 equilateral triangles. That's what the ET stands for. And I'm going to take it and multiply 2 by whatever the measurements are. The bases on all of these triangles is 9. Their heights are 7.8. So when I multiply 9 and 7.8, or 7 and 8/10, then I see that I get 70.2. And then when I double that, I have 70.2 times 2, and I get 140 and 4/10, or 140.4. But once again, we multiplied 2 different things with measurements in order to find their areas, so I have to square my label. So a tetrahedron, right, all 4 triangles are equal to one another, is the easiest formula when it comes to finding the surface area of a pyramid. But that's not the only type of triangular pyramid. So my second one that I need to look at is still a triangular pyramid, but it's not a tetrahedron. The way I know it's not a tetrahedron is 2 different approaches. First, I can look at the net of a tetrahedron. When I look in that top left, I can see that the base lines are all in straight lines, nice and evenly connected, so I know all of those triangles are equal or congruent to one another. When I try to do that with this net, notice that gap. That gap will always tell me that they are not equal triangles one to another, so it's not a tetrahedron. The other way that I can tell is when I start looking at the measurement. Because when I look at the height of the base triangle compared to the height of the vertical sides or the lateral side triangle, it's not the same. So if it's not a tetrahedron, then I have to have a different process to solve for that one. Now, this one, they already give me the net and it's labeled for me, and therefore I would just plug it in and start doing my formula for base times height divided by 2 for each of my triangles. But let's say that they don't give me my net, right? If I make a generic net and label it and it's already there, then, I need to know what happens when I get an assignment, such as you're going to see, where you're not given the net. So let's go from that approach. Let's say that we're just given this triangular pyramid and we don't have the net. How are we going to do it? So we're just going to make a generic net, and we're going to start with a base triangle. So when I look at that base triangle, I then want to look at the pyramid that they give me and find its measurements. Notice that we have 4 sides of that triangle that are all the same. So if I have an equilateral triangle with the side measurements of 4, I can label it. But then I need to notice and focus in on the height, and that's that dotted line once again, indicating the right angle for the height of that particular triangle. Then I want to label it. So my height of my base triangle is 3.5. Now, I'm just going to draw generic triangles. I try to make them look equivalent. And once again, I'm doing it and copying it on the computer. So it's going to look a little neater than what I would do it in my own handwriting and what I would expect from you. But they can be super tall and skinny or short and fat. It really doesn't matter as long as I can tell that I'm going to be using the same measurements for each of these. When you get older, then you're going to be challenged in 7th and 8th grade where it has a right triangle or an acute triangle or an isosceles triangle as the base. But right now, we're going to just do with equilateral triangles as our base, which means that the base measurement for all 3 of these triangles is still going to be the 4. But I need to find the height of what all 3 of these side or these lateral side measurements are going to be, and that's where the 5 comes into place. So I label the height of my side triangles, my lateral faces, my lateral sides, the ones that would come up to the point at the vertex. That's going to be 5. Now, I basically have 2 math problems that I'm going to do. My first is to find the base, and my base is just one triangle, so I know that I'm going to use the formula for a triangle, which is base times height divided by 2. And I plug in the measurements for the base triangle. The base measurements are, well, I have the base of the triangle as 4 and its height as 3.5. Well, when I multiply 4 times 3.5, I get 14, and 14 divided by 2 is 7. And once again, I set that over to the side so I remember that I'm not just going to do the next math problem and I'm going to be done. I have to finish it up and find the surface area for the entire thing. by adding my two products together. But let's look at what we have now. Now we have triangles that are our lateral sides, right, our lateral faces, and I know that triangles are base times height. But how many do I have? Well, I have 3. Now, can I cross reduce 2 and 3? That, before we had 2 and we had 4, and it makes a nice even number. Well, we actually can. If you take on your calculator right now and you type in 3 divided by 2 equals, tell me what you get. Get 1.5, right? So what we're going to find out is that if I have 3 equal triangles, and we know that they're half of a parallelograms, well, if I take 3 of them and divide by 2, then that is going to be the same as having 1.5. So the formula that I can plug in anytime that I have 3 equal triangles or 3 congruent triangles is doing 1.5 times the base times height. Now, if you prefer to take your base times height, divide it by 2, and then turn around and multiply it by 3, you can do that. There's nothing wrong with that. I'm just trying to make fewer math steps for you to help you out. If I use this process because I have 3 equal triangles and I do 1.5 times the base times height, I should get the exact same answer. So if I set that up, it's 3 equal triangles is equal to 1.5 or 1.5 or 1 5/10 times the base times the height. I know that I have a base of 4 and a height of 5 for those side triangles. So then I multiply, parentheses first, order of operations, 4 times 5 is 20, and then 20 times 1.5 is 30. Then I can add my 30 and my 7, because that's what surface area is finding the total area that covers the surface of the entire shape. When I add those together, I get 37. What's my measurement? Well, I look at my original diagram and it's feet, so I'm going to have square feet because I found surface area. All right, so that's the end of this particular introduction to finding the area of pyramids. Now, once again, we're going to have a review lesson tomorrow where you're going to take some notes and practice on 3 different shapes, one of which I'm not going to give you any shape at all, and you have to create that generic net. So it'll be important to follow along. But then that assignment is where you're going to have to take everything and go deeper. You're not only going to have to find the surface area of square-based pyramids or tetrahedrons or triangular pyramids, but then put it into word problems and know how to work it. But that's all of the surface areas that we're going to be doing in 6th grade. Our next lesson after that then is we're going to go back to lesson 9.1 and find the volume of these shapes. Then you'll do your test. But I'm going to let you know that we have a little bit more volume to do, because after all of this, we also need to be able to calculate the volume of cylinders, because that's not covered in our book, but it will be in our standards for 6th grade, but also expected to be on our standardized test. So as you're doing your assignment, look back at these processes. They're here, they're on your notes, as well as on your announcements for Canvas. And if you have questions while working it, because it is a lot of steps, then please come and ask.